Here is your help video for quiz 1.14. Alright, classify each scale factor as a contraction or an expansion. Alright, so first you need to know what these words mean. A contraction is making it smaller, and an expansion is making it bigger. Okay, so when we're dealing with scale factor, anytime you multiply by a number that's greater than 1, like if I make something 2 times bigger, I'm making it twice its size. So that would be an expansion. If I want something, if I'm multiplying it by half, that's going to make it half of its size, and that's going to be a contraction. So here's basically what we look for. We look to see if the absolute value is greater than 1 or between 0 and 1. So I'm going to write each one up here. If the absolute value is between 0 and 1, and by the way, for scale factor, we use the letter K. So I'm going to use that up here. If K is between 0 and 1, it's getting smaller. And if the absolute value of K is greater than 1, it's getting bigger. And here's the deal. We only care about the absolute value. A negative scale factor does not necessarily make it get smaller. What a negative does when you do a scale factor is it changes the orientation. So we'll look at that more in a minute, but for these purposes, we're just looking to see if the absolute value is greater than 1 or between 0 and 1. So 1.25, the absolute value of that is 1.25, and that's greater than 1, so that's an expansion. 3 is greater than 1, that's an expansion. Negative 2, if we take the absolute value, is positive 2, which is greater than 1, so it's an expansion. 3/4 is 0.75, that's less than 1, so that's a contraction. And 1/5, what is that, 0.20? So that is going to be a contraction as well. Alright, don't assume just because it's a fraction that it's automatically a contraction, because sometimes you have the bigger number on top, right? If you saw 7/6, that's actually going to be an expansion because that's actually greater than 1. So make sure you actually check to see what the decimal is. Don't just assume that all fractions are going to be getting smaller. Alright, let's go to the next one. Triangle x prime, y prime, z prime is the image of triangle xyz under a dilation through point xz equals 4 and x prime, z prime equals 5. What scale factor is used in the dilation? Okay, so this sounds like it's going to be super hard, but I promise you it's not. For scale factor, which we said we call the letter K, you have this formula that says the image over the pre-image. And that's really all you have to do. You have to take your image value, which in this case is 5, and you want to put it over your pre-image value, which in this case is 4. Sometimes it'll leave the scale factor as a fraction, 5/4. Sometimes it'll want it as a decimal. You have to be able to be comfortable going from one to the other. So this scale factor is either 5/4 or 1.25. And I don't even deal with negatives unless I'm looking at the picture. So the way I tell if it's positive or negative is I look at the picture. If the orientation is the same, it's positive. If the orientation has changed, it's negative. And what I mean by orientation is see how x and x prime are both on the top, z and z prime are both on the left-hand side, y and y prime are both on the right-hand side. The orientation has not changed, so I know that this is going to be a positive scale factor. Let's try another one. Kind of got cut off here, but it says graph the image of the given triangle under a dilation with a scale factor of 1/3 and center of dilation at 0, 0. All right, when you're doing a scale factor, you're multiplying it. So really all I have to do is I have to take each of these points, like this point is located at -6, 0, and I have to multiply each of those values by 1/3. So negative 6 times 1/3 would become negative 2. And 0 times 1/3 would become 0. So this new black point would be located at negative 2, 0. All right, let me change colors here and we'll look at another one. All right, if we do this point up here, this red point, it's located at 0, 9. I want to make it 1/3 of its size, so I'm going to multiply by the scale factor, which is 1/3. 0 times 1/3 is still 0. 9 times 1/3 is 3. So that's how they got that point right there. And then the last one, I'm going to take this one, which is located at 0, 0. And if I multiply it by the scale factor, anytime you multiply 0 by a number, it's still going to be 0. So that one didn't move. So this would be your new dilated triangle. And if you notice, it is 1/3 the size of the original. All right, triangle E prime F prime G prime is the image of triangle EFG under a dilation through point C. What scale factor was used in the dilation? All right, so we're trying to find scale factor. So I'm going to go ahead and write down my scale factor formula. Image over pre-image. So if you notice, GF is 8 centimeters and G prime F prime is 4 centimeters. Now remember, the one that has the primes is the image. That's the final thing, right? You start with just EFG, and then when you dilate it, you change it to E prime, F prime, G prime. So that's my image. So 4 is going to go on top. 8 is going to go on the bottom. And you could use this either as a fraction or a decimal. I'm going to go ahead and use, I'll put both. You can either have 1/2 or you could have 0.5. But now we need to check the sign. Remember I said when I normally do scale factor, I just do image over pre-image, and then I check to see if it's positive or negative. So for that, we're checking the orientation. All right, notice how E started on top, and then it ended up on bottom, E prime. G started on bottom, and it ended up on top, G prime. Notice how the orientation has changed. F was on the left, and then F ended up on the right. When the orientation changes, that tells you that that is a negative scale factor. So my answer here, my final scale factor would be negative 1/2 or negative 0.5. Be really careful to check those positive and negatives after you use your formula. All right. Graph the image of the given triangle under a dilation of a scale factor of -2 centered at 0, 0. So again, all we're going to do is we're going to take our ordered pairs. This one's at -3, -4. And we're going to multiply it by our scale factor. So I'm going to multiply each of those pieces by -2. -3 times -2 is a +6. -4 times -2 is a +8. So this new point would be over here at 6, 8. 4, 5, 6. Let's see, that's 6, 7, 8. So up here at 6, 8. All right, let me try the next point. So this one is located at -4, 1. Then you multiply it by the scale factor of -2. -4 times -2 would give me a +8. 1 times -2 would give me a -2. So this new point is going to be located at 8, -2. And since my graph got cut off, I'm going to go ahead and write those ordered pairs so you know where they're at. All right, then we have one more point. This point is located at -2, -2. Multiply it by your scale factor. -2 times -2 is +4. So this new point would be located at 4, 4. And then we could draw our triangle. Oops, I don't know what just happened there. And a couple things you want to double check. First of all, you want to make sure it's about 2 times bigger, or exactly 2 times bigger, which it is. And then you also want to make sure that your orientation changed, because remember that scale factor was negative. Here the blue was on the bottom, now the blue is on the top. Red was on top, now it's on the bottom. So our orientation has changed. So I feel really confident that we did that correct. All right, good luck.